Hello everyone, welcome to this online course on material science. This is lecture 4 in the module 1. If you recall, in the last lecture I started talking about different types of magnetism, where I mentioned diamagnetism as one of the types of magnetism. Now, to understand diamagnetic effect in a material, let us suppose that we have a magnetic north pole here and a magnetic south pole here. So the magnetic flux line will start from the north pole and it will enter in the south pole. So this is the magnetic flux line of this magnet. Now, to understand the behavior of the diamagnetic material, we will put a diamagnetic material in this magnetic field. And inside this material, we have certain species which are identical in nature. And these species can be ions or atoms. Due to the presence of this external magnetic field, this species will generate a magnetic dipole moment which will start pointing in the direction anti-parallel to the external field, all of them. So what will happen, the net magnetic dipole moment of this solid object will be directed in this direction. So the net magnetization is in the opposite direction of the external magnetic field. That's why when we define the magnetic susceptibility as a ratio between the magnetic polarization vector of the solid to the applied external magnetic field, they are out of phase because they are opposing each other. That's why for diamagnetic material, chi is defined to be less than 0. This phenomenon should remind you about the Lenz's law in your first year physics course, that an induced current generates a field that opposes the change causing it, right? So these moments are generated in such a way they are trying to oppose the external field. It seems a reappearance of Lenz's law. And also I want to note a very important point, that in different types of materials, different magnetism can coexist together and their strength compete with each other, and the strongest one usually wins. For example, copper is a diamagnet, but if you do some calculation inside the copper, there are two types of magnetism exist inside copper. One is called the Pauli's paramagnetism, and another one is the Larmor diamagnetism. But the strength of the Pauli paramagnetism is weaker than the diamagnetism. So diamagnetism wins and copper becomes diamagnet. This is a very important point. So different types of magnetism always can be coexisting inside the material, and they will compete with each other. Another important question to ask to understand magnetism is that, do you want to understand the magnetism at a single atom level, or is it a magnetism in a solid, in the entire solid? So the atomic picture is much easier, right? And they most of the time, they give us a very good idea how the magnetism occurs. For example, let's say every atom, right? We have some nucleus where the protons and the neutrons are there, and we have some bunch of electrons. I don't know how many of them, but they are just running around, right? So actually, this is very complicated dynamics of the electron inside an atom. But for magnetism, what we believe, or what we model this system, is that we will try to understand how these electrons generate a magnetic dipole moment. And then, if you understand what an atomic dipole magnetic moment is, then we will try to build up a solid by putting more and more this atomic dipole moment, which is an approximation, of course, because the problem is inside a solid, these atoms, they are not independent, right? So they interact with each other, and you know, when atoms interact with each other, energy levels kind of forms a band, right? Energy levels form a band, and we have to discuss the band theory of the solid. So it is really difficult to model magnetism inside a solid. So we have to be more careful, and we have to be more cautious about the model we are using for the atomic diamagnetism. We need to make several changes when we want to model the diamagnetism solid. So usually the atomic ones are taught because it explains the ideas fairly well. Also, before I end this lecture, I just want to mention some of the different types of diamagnetism that exist in literature. So one is due to Langevin, and we will find another one is from Larmor diamagnetism, and there is also a variant called Landau diamagnetism, but this one, the Landau one, requires a very advanced formalism in quantum mechanics. So we don't have, this is outside the scope of this course, but we will definitely be talking about the Langevin model and the Larmor diamagnetism in solid or in an atom, right? And also, before I want to end, I want to give you some reading. So this is the standard text that I've been saying, quoting for like last few lectures, and also for this basic understanding why atomic and magnetism and magnetism in solid is different. You should look at this book from by Professor Stephen Simon from the Oxford University Press. I think that's about it, and thanks for listening.